Let's talk about application of entity inheritance in order to separate audit fields from entities in order to avoid code duplication. And let's check out how to update the same centrally without actually duplicating the audit field generation logic, such as populating date and time of when the entity is being created and updated, and the updation or creation is done by which particular user, and so on and so forth. As per this diagram, I will be having two microservices on this example, which I have used to talk about exceptions before, and I will be posting the link up here on this video. And each service will have entities like car, engine, tire, driver, trip, likewise, and each entity will have to maintain audit fields to track who created and updated them and when those creations and modifications are actually happened. So all the entities will have to maintain a common set of fields like created by, updated by, created on, updated on, and record status. So this is actually according to this example, but those fields could be vary based on your requirement. However, those are kind of a common set of fields to all the entities. So this results in kind of an unnecessary duplication of code, and we can separate this from the entity mainly to gain more focus on the business aspect on the entity. Those are the two main design objectives that I am planning to achieve in this implementation. The first one is define a reusable set of audit fields for all the entities. And the second one is to have a centrally managed logic behind the audit field population. I can either leverage the JPA auditing functionality, or I can define an audit class and let all the entities to inherit it. Nevertheless, I will defining an audit super type and implementing the pattern manually, since it is quite straightforward. However, the primary fundamental which is used here is inheritance. Since the entities represent a table on the database, this has to be done with caution without impacting query performances. And there are multiple approaches to use inheritance in JPA, and let's talk about what those approaches are. First one is to use @mapped superclass annotated superclass with defined set of common fields, and the parent should not be an entity in here, and the child entities will inherit all the properties onto them. As in this example, ID and status defined on superclass, which eventually inherited and created on the car table on the database. So this is a perfect suit for my requirement. However, let's discuss other approaches also. JPA provides a single table approach where the superclass will be an entity, unlike in previous approach, and per class hierarchy it will create a single table. As in this example, ID and status both inherited onto car and truck classes. However, a single table is created on the database. And for duplicating fields, it will be creating a single column, like in this example chassis color, which are attributes of both car and truck. It will not duplicate them. And as you can notice, a new column is added by JPA as D type, which is known as a discriminator column. At the time of generating the table, it will get created by JPA, and this is to identify by which class the record is actually created. If the record is getting persisted with car, D type will be car, or if it is from truck, it will be truck. However, you can override the discriminator column using @discriminator column annotation, and the value can be override with discriminator value annotation. So you can change the column header plus the value also. You can create entities to inherit ID as foreign keys to the child entities, and as per this example, both car and truck will get only ID field from super entity. And this will create three tables on your database like vehicle, car, and truck. This will not suit for large data sets, since each record will attempt to join with parent, which will be kind of expensive and really less performant. Finally, you can create a table per entity. Unlike in join table approach, all the attributes from super type will get inherited, including the status column. However, there will be performance impact when you query on the super types which will use union to collect data from all the subtypes. However, based on the requirement, you can use polymorphic queries with explicit polymorphism type, and it will not return the subtypes when you execute a particular query. I will be using mapped superclass for my requirement here, since it decouples audit fields from all the entities, and the audit class will be a part of global jar deployed over repository management system, and it is for the global access across all the microservices. Next, we need to update the audit fields before persist the transaction, and despite including it on the service layer, you can stamp them prior to persist or update data on the data access layer, leaving the service layer to more focus on the business logic. However, this depends on your business requirement. If there are complex objects getting persisted within a single transaction, relational entities can get updated with audit fields on the service layer itself to avoid remanipulation of complex objects on data access layer. Anyway, the audit field generation will be separated out onto a global util, mainly to ensure no duplicated auditing logic is used, and they are generated and collected according to a predefined template across all the microservices, which will be convenient for any post processing, like if you are using those information to analytics or troubleshooting purposes, then you will be having same format from each and every class, from each and every microservice. So it is kind of convenient. And let's check out the implementation related to this. So as we have seen, the audit class is located within the utils folder like this. Then I have created by, updated at, status, and those common auditing fields. And as you can see, the superclass is mainly mapped superclass, so it is not an entity. So let's see how this is inherited. So if I go into the car entity of the car microservice, you can see it extends audit class, and the car domain object is primarily focused on the car related attributes only. So it is having registration number, chassis color, engine, and the tire relationship. It doesn't care about anything about the audit field. And you have the same in the trips microservice also. We'll quickly check the trip object. So it is having a trip number, distance, and all the trip related information. So all the audit information are separated from this object. So let's check out how the audit fields are getting updated in here. So if I go to the trip DAO, within the trip DAO, before saving the trip object, I am stamping the audit fields in here. So if I go to my business logic save method primarily focus on the business logic related fields. So it doesn't care about how the stamping of the audit fields should look like. So let's go and see how those values are represented on the database. So I'm using H2 database for this demo. Those are my 3 tables created related to car microservice. So as you can see, related to the record that I have created on the trip, so it stamped the created at, created by, record status, updated and updated by fields. So all those fields are separated from the business entity. And you can find more details about starting up this complete project. So I have covered it one of the previous video that I have done in order to cover handling exceptions. All the links are mentioned down in the description section, and the link to the repository also mentioned there. You can go ahead and try by yourself. I hope this video is helpful for you to get an idea about practical usage of JPA Inheritance, and let's meet again in another interesting video like this. And please make sure you post notifications are on. Until then, stay safe.